You're welcome to solve this nice exponential equation, which is x minus 3 raised to power 4. This is equal to 5 to power 4. So what are the values of x? The first thing here, let's take 5 to power 4 on the left-hand side, so that you'll have x minus 3 to power 4, subtract 5 to power 4. This is equal to 0. Next step here, we can express x minus 3 to power 4 as x minus 3 raised to power 2. Again, this raised to power 2, subtract 5 to power 4 can be expressed as 5 squared raised to power 2. This is equal to 0. Now, you find that this is in the form of a squared minus b squared, which we can express as a plus b, a minus b. The next step here, a is equal to x minus 3 to power 2, and b here is equal to 5 to power 2. And that implies that a plus b, this is equal to x minus 3 to power 2 plus 5 to power 2. This is equal to 0. Let's call this equation 1. The next step here, a minus b, this is the same thing as x minus 3 raised to power 2, subtract 5 to power 2. This is equal to 0. Let's call this equation 2. So let's solve equation 1, that is case 1, which is x minus 3 squared plus 5 squared. This is equal to 0. Now here, x minus 3 squared, this is in the form of a minus b squared, which we can express as a squared plus b squared minus 2 times ab. Now, applying this algebraic identity, then here we'll have x to power 2, so that is subtract 6x plus 9 plus 5 squared, which is 25. This is equal to 0. Now here we have x to power 2, subtract 6x, then plus, this is 9 plus that 25, and this is equal to 34. This is equal to 0. Now from what we have here, this is a quadratic equation of the form ax squared plus bx plus c. This is equal to 0. So from this quadratic equation, a is equal to 1, b is equal to minus 6, and c is equal to 34. So to solve for the values of x here, we apply the quadratic formula, that is x1, x2, this is minus b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. Now, applying this quadratic formula, let's substitute the value of a, b, and c, so that here we'll have minus 6 plus or minus the square root of b squared, which is minus 6 squared, subtract 4 times a, which is 1, times c, which is 34. All this divided by 2 times a, which is 1. The next step here, we have minus times minus 6. This is 6 plus or minus the square root of minus 6 squared. This is equal to 36. Subtract. Now this is 4 times 34. Now 4 times 4 here is 16. So this is 6, carry 1. Then 4 times 3, this is 12 plus 1, 13. So we have 136 divided by 2 times 1. The next step here, we have 6 plus or minus the square root of 36 minus 136. This is minus 100. All this divided by 2. The next step here, we'll have 6 plus or minus. We can express the square root of negative 100 as 100 times minus 1. All this divided by 2. So in this case, we'll have here 6 plus or minus the square root of 100. This is 10. The square root of minus 1, this is I. then divided by 2. Now here, we can factor out 2, so that here we have 3 plus or minus 5i, all this divided by 2. So let's simplify here by 2 by 2, so that now x1, x2, this is equal to 3 plus or minus 5i. So in this case, we have x1 equal to 3 plus 5i, and x2 equal to 3 subtract 5i. Now these are two complex solutions. These are two complex solutions here. Now let's proceed to case 2. Now we have case 2 here, which is x minus 3 squared minus 5 squared. This is equal to 0. Now this is in the form of a squared minus b squared, which you can express as a plus b, a minus b. Now in this case, we'll have here x minus 3 plus 5, and here we'll have x minus 3 minus 5. This is equal to 0. So here we have x minus 3 plus 5. This is actually x plus 2, and this is equal to 0 as one part. Here we'll have x minus 3 minus 5. This is minus 8, and this is equal to 0. So that implies that here x3 is equal to minus 2, which is a real solution here. And we have that x minus 8 is equal to 0. So that means that x4 is equal to 8, which is also a real solution. So now we have 4 solutions here. We have 4 solutions. 4 solutions. We have that x1, x2, this is equal to 3 plus or minus 5i. Now here we have 4 solutions, x1, x2, which is 3 plus or minus 5i. That implies that x1 is equal to 3 plus 5i, x2 is equal to 3, subtract 5i, x3 equal to, we have minus 2, and x4 is equal to 8. So these are 2 real solutions, and these are 2 complex solutions. 2 complex solutions. So let's verify that x1, x2, x3, x4 satisfies the equation. Let's verify that x1, x2, x3, and x4 satisfies the equation. Now, if you recall here, we have that x minus 3 raised to the power 4, this is equal to 5 to the power 4. Now, substituting the value of x1, we'll have 3 plus 5i, subtract 3, raised to the power 4. This should give us a value of 5 to the power 4. Now, in this case, we have 3 minus 3, this is 0. So we have 5i raised to the power 4. This should be equal to 5 to the power 4. So we can write this as 5i times 5i times 5i times 5i. This should give us a value of 5 to the power 4. So here, 5 times 5 times 5 times 5, this is 5 to the power 4. Multiplied by I times I, this is I squared. Multiplied by I times I, this is I squared. This should give us a value of 5 to the power 4. But I squared, this is equal to minus 1. So here we have minus 1 times minus 1, this is equal to 1. So this is 5 to the power 4, this is equal to 5 to the power 4. So that implies that the left hand side is equal to the right hand side. So x1 satisfies the equation. So let's check x2. We have x2 as 3 subtract 5i minus 3 raised to the power 4. This should be equal to 5 to the power 4. So this implies that 3 minus 3, this is equal to 0. Then we'll have minus 5i raised to the power 4. This is equal to 5 to the power 4. So again here, we'll have minus 5i times minus 5i times minus 5i times minus 5i. This is equal to 5 to the power 4. So this implies that minus times minus times minus times minus, this is positive, then 5 times 5 times 5 times 5, this is 5 to the power 4, multiplied by, this is I times I, this is I squared. Then here, multiplied by I times I, this is I squared. But I squared, this is minus 1. So minus 1 times minus 1, this is positive 1. So 5 to the power 4 is equal to 5 to the power 4. So x2 satisfies the equation. Now let's check x3, which is negative 2. We have that x minus 3 to the power 4. This should give us a value of 5 to the power 4. So x3 is equal to minus 2. And given that x minus 3 to the power 4, this should give us a value of 5 to the power 4. Let's substitute here. This is minus 2 minus 3 raised to the power 4. This should give us a value of 5 to the power 4. So minus 2 minus 3, this is minus 5 raised to the power 4. This should be equal to 5 to the power 4. So here we have minus 5 times minus 5 times minus 5 times minus 5. This is equal to 5 to the power 4. Now this is 5 times 5 times 5 times 5. This is 5 to the power 4. Minus times minus, this is positive, and minus times minus is positive. So we have 5 to the power 4. This is equal to 5 to the power 4. So x3 here satisfies the equation. x4 is equal to 8. Now, given that x minus 3 raised to the power 4, this should give us a value of 5 to the power 4. Let's substitute x here with 8. We'll have 8 minus 3 raised to the power 4. This should be equal to 5 to the power 4. 8 minus 3, this is 5 to the power 4. This is equal to 5 to the power 4. So the left hand side is equal to the right hand side. And that implies that the four solutions, that is the four solutions, satisfies the equation. So kindly follow the steps, like this video and subscribe.